Hello students, Ms. Slyman here, and I'm going to talk you through Lesson 36 about our MVT application. So this one starts with this idea that we've got this person, Leanne, driving on a highway, and she gets a speeding ticket in the mail and a printout of her E-ZPass records. So E-ZPass is like toll booths along the way, and it scans this device in your car. So in Rock Falls, that's mile marker 45, and she's got a timestamp of 123. Maple Park, mile marker 100, timestamp 211. Elmhurst, mile marker 140, timestamp 240. So how many hours did it take her to go from Rock Falls to Maple Park? Well, it was from 123 to 211, so that's a total of 48 minutes. And of course, to convert 48 minutes into hours, then I'm just going to divide by 60. It's 0.8 hours. The distance between the two is 55 miles. So it could be that there was times that she was going faster or slower on the trip. Well, let's pause here and think about our connection to MVT that we saw in Desmos. Basically, we have a bunch of points. So we're going to make an x-axis that has a time of minutes. So let's see if I can draw on this. No. Let me move over to here. So if I think about what we've got distance on this side, and we've got time on this side. So let me plug in my pen. Sorry. With my distance, all right, we've got distance and our time. So we could have time since leaving Rock Falls. So 0, and then 48. So if I'm going in minutes, and then between these two, that's a change of 29 minutes. So 48 plus 29 is 77 minutes. And then we went a total of 55 miles. And then we went an additional 40, puts us up to 95. So we've got something that looks like here are our points. And we don't know what our function looks like along the way. But I could say that I have secants between these two. And then I have another secant here. So converting from minutes to hours, I can calculate my miles per hour. So we saw that this one had a slope that was 68.75 mph. If you calculate out this one, which is what they ask you to do down here, so if we do that, and we know that she was driving continuously on the highway. It's a tollway, so she didn't exit in between because you go between the two tolls. So we've got some sort of continuous function between here and here. So for our continuous function, we don't know exactly what it looks like, but we know that we'll have a tangent along the way that has the same slope. So between these 2 points, maybe at some point I went faster than 70 miles an hour, so maybe I had a steeper slope at some point. Maybe I had a lower slope at some point. For sure, I had an equal slope at some point. So we don't actually know what it looks like between these 2 points. We just know at some point we had a slope of 68.75. Over here, same idea. We don't know exactly what it looks like, but at some point we have a slope of 82.75. We're also going to have all the slopes in between those two as I get between the two. So if my speed limit is 70 miles an hour, I don't know if I speeded between these 2 points, but definitely between these 2 points, we must have broken the speed limit of 70. Because certainly at some point between those 2 points, I'm gonna have that same slope. So that's what these answers are going through. Of course, you have these answers in your student folder, and that's what this is talking about. So distance is continuous and differentiable. And at some point, she must have had a speed above 70 miles per hour. She also must have hit her average speed at least once along the trip. So these are our ideas to toolkit, excuse me, that for continuous and differentiable functions, we're going to have our slope that at some point matches the slope of the secant. And remember, this full definition was written out on our Desmos activity as well. So I'm going to leave these CYUs for you to do. Remember, you can go check your answers. They're in our student folder. And of course, you can ask me when you have questions.